In the last video we talked about the value of x being 2 and then what happens when it increases, and we could put a breakpoint here so that when we run the program it's going to stop here, and x has got the value of 2 obviously, but if we press the F8 key then you'll see that x becomes 3. It's just incremented by 1. So we're showing the idea of right to left now, so that it's taking the value of x, adding 1 to it and putting it into the new value of x, which we can see here. X is 3, so when we could just continue to run the program, so click that and you'll see that x has got the value indeed of 3. Okay, so now what I want to do now is to think about if I had two values here, 2 and 3, and I want to swap the two values. So the 3 will be here and the 2 will be here. Well, let's think about how we might go about this. If we now, for example, you might start off by doing something like this. You might say that range A1 is equal to range A2. Now what does that mean? Well, it means take the value that's here, remember it's right to left, and put it into here. So in terms of the spreadsheet it means take the value of 3 and actually move that into here, so they both become 3. And that's not really what we want to do. We could check that out actually, that is indeed happening, by putting a breakpoint here and then click the button and then check out these two values here. That's got the value of 3 and that's got the value of 2. So when I press the F8 key you'll see both of those are overwritten, so they've both got the value of 3, which is not what we want. So I purposely left that dim x as integer because I know that I'm going to be using that somehow or other. The way we're going to use it is the fact that this range A1 is gone. We don't know what that, we've lost that value. Let me just restore this before we go any further, put the 2 and the 3 here. Okay, now so what I want to do is I'll do a control drag on this, hold the control key and drag that up. And now what we want to do is to put x equal to that value. In other words, we're going to store that value into x. I'll see if that works. I'll put a breakpoint and click it. Now this has got the value of 2, but you can see that if I press the F8 key then the 2 has actually stored in the x, you see. Now that means that it's available to us later, but what happens here, we've got the 3 there, this is 2, and if we press the F8 key you'll see that value has been obliterated here and that's become 3, and correspondingly on the spreadsheet you can see that they've both got the value of 3. So I'm going to stop the program because that's not what we want. Now, so what can I do? I don't know why that 2 is doing that. Okay, so 2 here is what I meant to do, so that's a 2. Okay, now so what do I do? So at the moment you see this has got the value of 3, this has got the value of 3, but we want to bring back our value of 2. Where to? Here. It's going to be placed into A2, you see. So we'll start off by saying we'll control drag that down, and that's got to be made equal to what? Well, it's got to be equal to the value that we've lost, but it's still stored in x. So if we try that out, let's just, without further ado, we'll see if the program works. So if I click the command button, you can see that it's working. It swaps the 2 and the 3 up here, and continues to do so at each run of the program. What I'll do, I'll put a breakpoint in here just to remind us of what's going on. So I'll put a breakpoint here, click the button, and now this has got the value of 3. When I do an F8, it stores the value there, and here this has got the value of 2 and this has got the value of 3 because there's nothing changed there. But when I do that's got the value of 3. And when I do an F8 you'll see they both become 2 in this case. And now, but don't worry, we've got the value of 3 has been safely stored, and that if I now press F8 again, that will store the value of 3 into this cell here. Right, and obviously now if you were to run that again, you could I'll just quickly do that actually. I'll just run it again and stop it and then run it. You see this has got the value of 2 that the value of 2 gets stored into there when I press F8, and then this value, which is 3, will overwrite this value here, the A2, so F8 again, and now, but don't worry, we've got the 2 which is stored there, and that will therefore be returned to range A2. If I do F8, you can see that now this has got the value of 2 that's been restored, and therefore the values get swapped as we go along. Something a bit different now if we want to show the idea of a message box. So I'll just take this code out of my book or the manual and paste it in here, save us a bit of time. And now what's happening here? Well, we've said that the value of x is equal to 2, and we're going to, we could put a let in there if you want to, just to remind us what we're doing. We're letting that value equal to 2, meaning right to left. Now this statement here, the message box, a message box, well, let's see what happens. We'll click this button and it says the value of x is 2. Now the message box always requires string, a bit of text. So you can see here, that's what we're supplying with, a bit of text here. There's a space there, you'll notice, and that corresponds to the space being here. Now, C string, that means convert to a string. So you take the integer value here, which is 2, and convert it to a string. So you make it into a bit of text, and that means you can concatenate it, and you'll have one nice piece of text in here corresponding to this one nice bit of text in here. Now, so that's what that means, convert to string in order to concatenate it. Right. Now, so therefore, if we got rid of this convert to string, you would say that's not going to work, because that's an integer we've got here, and you can't join an integer to a string. Well, let's see, it's not going to work, is it? Oh, that works. Well, the thing is that Excel is just being very forgiving here, and concatenating. It says, oh, I know what you're trying to do. You're trying to join 2 bits of string. I will convert this for you internally. It's called an implicit conversion. Quite clever, really. But it can therefore be very forgiving. Well, I mean, this is pushing the boat out a bit too far, isn't it? If you try that, that's just an integer. Does that work? Goodness me, that works as well. So there you are, a message box, which is very forgiving. Now, if we can use a comment. Now, a comment means you can put an apostrophe there. And if you put an apostrophe, then when you that won't take any effect on your program. It's useful to having little reminders for yourself to say what the program is doing. Now, in this case, so this is not having an effect on the program. What will happen if we click the button? Oh, message box 0. That's interesting, because we've dimmed it, and the default value of x is 0, and that gives us the 0. So that's the idea of a comment button. Now let me explain what option explicit up the top means. Well, let's try a different variable name. Let's say we'll call it sales, for example. And then we say let, oh, we don't need the let. We can say sales, the value of sales is equal to 2, and then we want a message box at the value. So that's just a variable name. That might mean something. So you click that, and the program still works, no problem. But what happens if I misspell something here? You'd expect the program not to work. Well, it doesn't. And that's because variable not defined, it really should say variable not declared, but never mind. It says there's an error. So we can therefore stop our program, and then we can do an undo, and then just run the program and make sure it's reset and run it, and it still runs just fine. But this option explicit, what that does is it makes sure that your spelling is correct, but it also makes sure that you dim your variables. You see, if I didn't have that line, I'll just comment that out. And by the way, you can comment things out by using that button up there. You probably won't have that on your, but you can go through the options and put that on your toolbar. But if I click that, you'll see it comments that line out. Now, if I try and run the program, oh dear, the variable is not, I should say variable not declared, but variable not defined. That's good enough for the moment. Okay, so you see, it's a safety measure that right. So. Therefore, if you have option explicit, you must dim your variables, and that will, if we do, as I showed you, it will. See, some people will run without option explicit, I'll just get rid of that option explicit. It still will work at that stage. But you see, if you here, now watch this, if you have an error in your thing, you expect the program not to run, but what happens, it actually runs, but it gives you a value of 0 because this value of SLES, whatever it is, that has got a value of 0. So the program is working, but it's not, if you know what I mean. So let me just click that. Okay, you'll notice that when you have option explicit, don't have option explicit, you don't need to have any dim statements. So you know that program will still work, but it'll give you the wrong answer. So always use option explicit. Programming is not about making programs work, it's about finding out when they don't work, what you do about it, and that's a good use of option explicit is to put in a safety measure to make sure you include all your variables correctly. Let's talk about other variable types. Now, I've got some other variable types here. I'll just copy these across and I'll just explain what they are. If I paste this in, now let's take a look at this code here. It says we're going to dim lots of variables. Well, we haven't got an option explicit. I really should put that back in. And okay, and we're dimming lots of variables, and then we're giving these variables values, you see, and then finally we're printing the stuff out to the screen, which is here. I'll just run this and just see what it does. It gives us all of the. Let's look at these one by one. It says LG as long. We did have before as an int, well, integer, I should say, and it might well be an integer, because an integer is a whole number, but so is a long. A long is just the same thing, but it's more accurate. It's got a bigger capacity than an integer. A single and a double, well, they are decimal values. You can see it prints out to the screen. But yeah, you see how these are being printed out here. Range A1 is that variable LG. You can call these what you like. I've just said LG. You could call them lots of things, you know, but that's a variable name. Now, it says it's a single and dB is a double. A double is just, first of all, a single is a decimal number, as you can see on the left. A double is also a decimal number, but it's got a higher capacity. Just as long has got a higher capacity into integral values, so has double got a higher value of decimal numbers. We've got TF as a Boolean. Now, a Boolean can either be true or false. You can see that here. Here you've defined TF as being true, and it prints out true onto the spreadsheet, as you can see. We have a date variable. Now, date, you can see you've used those hash marks to indicate a date, but they're quite unreliable, those hash. We'll talk about those later, but for the moment, that's putting in a date you can see on the spreadsheet. Coming back now to the variant. Now, a variant is like the queen in chess, if you like. It can be anything. It can be single, double, Boolean, date, long, whatever you like. And you might say, oh, hey, this is great. I'm going to use variants all the time. Why bother about an integer? It's not a good idea. Once again, we're trying to make our programs future-proof. And it's a good idea to get in first. And if you know something's going to be a whole number, then make it a whole number. Then if it's something, if you try and make it a decimal, then it'll kick up and tell you there's an error. So please be as explicit as you can. If you make life difficult now, it makes life a lot easier in the future. As I say, programming is not about making things work, it's about what to do when they don't work. So on that note, I would always use option explicit, and I would always be very explicit about what type of variables I'm using. Having said that, which means I'm going to contradict myself, it means that a variant is very, very useful in Excel, and you use them lots, because sometimes when you're picking up things from the spreadsheet, you don't know whether it's text or it's going to be a number, so it's very useful. So I'd say in Excel you're excused for using variants. But notice that if we just get rid of that as variant and run the program again, you see it works perfectly. I might go down and just change that variant just to show you that a variant can be anything. It can be a bit of text, and when I run that, you'll see instead of saying 2.6 down here, it gives me ed, which is a bit of text. So variant is very versatile. But notice how if I don't have any specification to the type, get that word type. This is a single type, double type. This is a Boolean type. Now this is the default type, which is a variant, you see, so the program will still work. But that has a little danger. Let me explain. If I take this LG up here and I move these two lines here onto the same line, I put a comma in between, does my program still work? Well, yes. So if I just click that, you see there's no change at all. So that's fine. But watch out, there's a bit of a danger in this. That what about this? I'm going to get rid of the as long. Now, what do you think LG is going to be? Do you think it's going to be a single? Well, you could be forgiven to think that it is a single. In fact, it's not. You see here when we had the variant, we didn't specify what it was. Then we're not specifying what LG is. So it is indeed a variant. The program will still run because LG can be 205. Why not? That's a variant. But be careful of that. I do recall I had a bit of a problem with that error. It took me half a day to solve, I think, because I didn't specify properly what LG was. Okay, I think just finally a bit of extra demonstration of arithmetic expressions. So if I just try this bit of code in here, and if I put, say, the number 8 in here, and I'll get rid of the rest of that stuff. Nice way to get rid of it, remember, just to drag back up. Now, what is this going to do? Well, first of all, it says dim is a single, and then it says range A1 value is plonked into X, or range A value is X. So what is this going to do in here? It's going to take the value of X, multiply by 3, then divide by 4. So you've got 8 times 3 is 24. Divide by that gives you 6. And then finally 6 plus 3 is 9. It's the old BODMAS where you do the multiplication division first, and then you add stuff on or subtract. So let's just see if that works in the range B1. So B1, of course, is here. That's where our, yeah, so that gives you the value of 9. You can try other bits and pieces. For example, this is the way that you write exponentiation. So that means x raised to the power of 2. You could put in, you could use brackets. You could change the, let me just go back to what we had before. If in this case, let me see, if I put brackets around that, it would mean do the brackets first. So let's see what's going to happen here. It's going to give you some sort of decimal number. So what you're doing, you're taking the value of, let me just put a breakpoint here and I'm going to run that. It takes the value of 8 and then multiply by 3, and then 8 times 3 is 24. 24 divided by 7. That looks like the result here, 24 divided by 7. So that's just the usual, and you'll be pleased to know that it's very much the same as Excel itself. So, okay, alright, there is an exercise which you could do. What I would like to do is to put a value of something in here, and what I would like you to do as an exercise is to MsgBox the value of that plus the VAT. Right, so you take this and work out the VAT and make a MsgBox which says the VAT on that is such and such. So I'll leave you to do that as an exercise.